Okay, here we go. A little PLC3 regroup, and just won't take very long. Just want to say great job so far. I know that we've had a lot of new equipment, new software going ahead and setting it up, and we said we're going to have that because it was a new class. Reminds me a little bit of ELTE 261 when I first put it together. I threw, just way too much information and way too big of labs and everything in the first iteration of that. And that first group of students really struggled because it was just so much more than you guys ended up getting. And so, once we get through this, we'll be able to right size it to be sure that we get enough lab time and enough time to work through everything. The biggest thing so far, I think, would be the networking. That kind of slowed us down just a little bit, but I'm not too worried about it. We are really jumping around the networks and the switches and everything, a lot better than we were to start it out. So let's just do a little bit of a review here, schedule review. So week 5, we're just going to do a little regroup here. That's what I'm giving you right now. Real short, no quiz, no homework. Take a look at where you're at and stuff that you've turned in the next topics. We're gonna then next time I see you guys do the barcode scanner lab. The main thing here is the software, or not a main thing, but a big thing is the software install. So you want to be aware that install is going to take a little bit. So you might want to get that going right away, and then you can start moving on to your user-defined tags, and then by the time you're done with that, maybe that software will be installed. I know quite a few people went there, and also Mark had downloaded that and has on a flash drive, and he was sharing with everybody so they didn't have to do the download and then install. He got the installer, so you guys figure that out right away when you get in there on Tuesday. And then after that, we'll go back to the analog lecture where we'll have the barcode quiz and the analog homework and stuff like that. So I think a lot of people already turned this in. I might have pushed that out there, but it didn't necessarily need to be in because we're just going to kind of back it up a day here. And then we'll do the analog lab. And then the 2 weeks after that, rather than try and do all the temperature measurement and PID into a single lab, I'm going to back it off a little bit, and we'll kind of spread it out over a couple of weeks so we can dig into the temperature measurement activities there, analog cards, thermocouple cards, pressure transmitters, all that kind of stuff. So that's kind of where we're at. I think we're doing good. So the progress update is, are you behind? Well, no, you're not. There's a lot of people partially done with labs here and there. I wouldn't get too hung up with it. I wouldn't probably move at this point. Everybody's kind of did a lot of networking, and I would probably move along on the barcode and get going on that. So overall, I'm generally happy with the progress. Once again, I don't think anybody's behind. You're getting a lot of quite a bit out of each lab, and if you feel like you're getting behind, you're not getting your money's worth. I did put a lot of excellent reading online, so you can just kind of get caught up there and see what's going on. This network stuff, it's awesome. When I want to put some resources out there, Alan Bradley has just got so much networking information out there, their documents, which just goes to show you how important this IT-OT convergence is, because like I said, as we pointed out before, a lot of this is kind of going to be the PLC people having to know quite a bit about this networking thing, not necessarily the IT department, because they're not going to be familiar with the automated systems like the PLC people are. So excuse me. So we'll keep going. Now, it actually turned out pretty good that we're doing this today because I got a little bit of cold going on. So the student network shared it, and that was what we got into a little bit of an issue with, and it took a little more time than we wanted to, because we were out of sync, kind of because we were partners were sharing racks, so they had to hey, I'm taking the PLC or I'm taking this IO, and if you got out of sync with that a little bit or you weren't in the same place, it got a little crazy. So that's what it's connecting across the different racks while trying to do individual labs, especially when the group wasn't at the same time, was a little bit of frustrating. But I'm happy that we kind of worked our way through it. People came in, some people were coming in at different times, working through some of their different classes, whatever worked. I think we learned a few things along the way. So, what did we learn, just to kind of regroup on the networking again, because that did kind of that was a bit of a pain for a while. So, backplane bridging. So when you're trying to bridge up, and here I got it showing a couple of items here. I got a couple racks here, each one with a CPU and each with an input-output card and AENTR. You're probably going to get better results if you just bridge using the ENTR or the EN2TR, or now they got ENT3Rs and 4TRs. But this is just showing just the ENTR. You're probably going to get better results if you just use the bridge into the bridge, okay? When you want to look between racks. The 5581Es that we have, the bridging can just be a little bit confusing, especially when we were trying to connect over multiple networks. So they are cool that you can, USB in and make connections, and you can set another IP address, and just all this other kind of stuff. But it can be a little bit confusing. I recommend just using your bridge, coming into your bridge, and then being aware that the way that this populates on links is just a little bit confusing, that you got to be sure that you're adding anything to the right Ethernet bridge. And that's why we got in trouble, because people were accidentally adding stuff kind of onto the bridging that was shown here on links, when really we wanted to connect on the backplane, backplane bridging using the ENTR. So my advice, use the EN2TR. Now, we did do remote IO on the same network, and this once again got a little bit off sometimes because we had partners not at the same place, and we came into the issue that you can share your remote rack input modules because you're just monitoring the status of the input, but you weren't really able to share the output modules. Probably not a good idea to try and share the output modules because they get owned by the processor. So as soon as this one owns the output module there, then the other one won't connect to it. So the first one here is in the same network, 192.168.1 dot. All these items have a different item here. And you see me going from the bridge here into, let's say, remote Ethernet IP. This will bridge up to the ENT2R here. And so these would all populate on the network, and you could use the I/O from a remote rack. Notice there's no CPU in this rack over here. It's just being treated strictly as a remote I/O rack, just like this would be right here, a remote I/O rack. And then here's my local rack. And so that's how you do remote I/O. There's other types of Allen Bradley remote I/O out there. We did do, in the past, device net, but there's just a ton. But it's just showing the Ethernet on a single 192.168.1 network. Now, this one's here is showing two processors. So this has got a processor. This has got a processor. Yeah, you can use the I/O on a different processor's rack. That's not a problem. Just be aware that if you claim some of this I/O over here, if you own some of the I/O over here, then you can't. Then this PLCO over here can't use it. So just be careful of the ownership if there's multiple PLCs. If there is multiple PLCs and you kind of want to share information, once again, you can kind of quote share the input, because you're just looking at the input status of these cards. But the output data, you would, if you wanted both of these to really utilize that output data on output card, or excuse me, you want to push that out, you would have to use produce and consume tags, and we did do that, where we had one producing some data, and you can produce whatever you want. We had a problem doing Boolean, and so we had to use that down at the word level, the bit level of the word. But you can do dents, reals, time bases, whatever you were doing there. You can do it versus produced and consumed if they're on the same network, 192.168.1. Okay, and that seemed to go well. Now, when we had different networks, and that's what's showing here. And, these controllers here, I got these trying to bridge up on the PLC, but even if I was trying to bridge up on the Ethernet, on the Ethernet bridge right here, the ENT2R, it's not going to work because they're a .1 network and a .10 network. At this point, you're going to need a switch to do some inter VLAN routing, okay? And that's what we did. We added a static switch, and the static switch, when you configure it, we typically gave it a VLAN of 192.168.1-1. That's pretty safe. And then we set a second VLAN of a 10-1. And then at this point, you can, once again, share the I/O across here. You can share the input cards, but, be aware the output cards are still going to be kind of owned by those controllers. We got around that before by using produce and consume tags because we wanted to look at what was going on with the output and kind of share that. But the problem is produce and consume tags will not work across different networks. If you want to take a look at that, if you do want to take a look at that output, or you want to share some timer data or counter data or whatever. And then so what we did was we used the messaging instruction. The messaging instruction we can share across the different networks. All right. For our HMI connections, we plugged the HMI in here, and let's just throw it on the 192.168.1 network. Okay. That's what it is. But because if this switch is set up right, it just sees everything. It's seeing the .1, the .10s, whatever we set up for our VLANs. If it was working right, we're definitely seeing everything here. And once again, if you're probably doing this right, you probably want to bring this into the bridge here, and bring this into the bridge to keep it working like what you want, depending on the functionality of this controller. But the HMI here, when you add the HMI, it can pull, these fields in here, these I/O fields, or whatever you got going on here, or these indicators. It can pull the status from this controller, and it can pull the status from this controller. Multiple controllers if you set up the pass-through connections correctly when you run your FactoryTalk links. So this HMI can be showing what's going on multiple PLCs on multiple networks. Now, that could be a problem, and that was another thing that was happening. We just had a lot of networks going on here, a lot of data, a lot of subnet, just a lot of numbers going around, and you get confused about what's going on. And then if you add all this stuff to the wrong ENET, because the 5581 Ethernet bridge is a little bit different on links, instead of just adding into the bridge here, stuff's not working, it gets lost. So is it better to message the information to a single controller and then just have one pass through to the HMI? If you just message everything back to here, you have all the values then, and then that HMI then is just tied to a single connection back to the kind of like, I call it the master PLC, I guess. Yeah, that might just be the better way to do it. And then you can, you want to troubleshoot something, you can just come into this first PLC, and then you can look at all the tag data with them, because you're getting messages from the other PLC. But if you don't use messaging, and then you come in this PLC and you can't find it, well, you're like, all right, I got to walk over, take my computer, log into this one, find what I want to look at. Oh, I don't see what I want to look at there. Walk over to the next PLC, connect up to that, right? But if you just send it all back to a single PLC with messaging, maybe that's cleaner. Then maybe that's cleaner for you guys. Okay, just something to think about. Gateway. So the gateway certainly could be a major source of network troubleshooting. We had just a little issue with that because we hadn't set our network adapters to a gateway of 192.168.1, which is what many of us had set the first VLAN for. It needs to be set to the VLAN of Stratix. A single network will not need a gateway. So you probably want to go and broom out all of those gateways for the different networks. But yeah, the gateway was a bit of a trip for some of these. And then another thing is, man, Links was acting weird at times. We're like, man, this all looks good, boom. restart the software, restart the computer, or recycle the power on the items, and then boom, stuff works again. We had a lot going on with the networks, and we were making all these changes and everything. Some things get scrambled a little bit, and sometimes that's what you got to do. Subnet mask could be an issue on troubleshooting. A mask of 255.255.0 is great for the single network, but then we had to change the third octet to look at another Class C network here. But you're going to need advanced subnetting and subnet masking if you're going to try and bridge A, B, and C networks, which, big companies might do that. They might be having some supervisory control going on where they've got A, B, and C networks kind of mixed together, and they're pushing it all up to the web or something. So we didn't get into that much of that or try and set anything up like that, but you're certainly going to see more and more and more of that kind of stuff as we go on. So that was kind of the moral of the story for the networking. As we move on, I suggest just resetting your switch to reflect a single VLAN on the 191.168.1 network, just so you don't have connection issues. We're going to be sharing analog input modules because I only have so many thermocouple setups, and so we can just set up a couple of the racks with these analog inputs from the thermocouples, and then run an Ethernet cable over there and steal the data from the remote racks. So you want to just be careful that all your USB to Ethernet adapters, bridges, switches, whatever you're using, do have unique 192.168.1 IP addresses. As we move on, let's talk amongst the class. I'm glad we only got 5 people because we were already having problems last time. If you get one and you're in trouble, right? And then don't forget to clear out the gateway of those devices because depending on whose rack is which and what your ENET bridge is and all this kind of stuff, we want to be sure that everybody can take a look at them. Unless some of these items automatically reset to 192.168.1-1 as the gateway, such as we talked about the remote Ethernet IP units. So to sum it up, that's it for this week. No quiz, no homework. Hopefully we'll get in and finish up that barcode lab on Tuesday, get the software downloaded, and work your way through it. It's a bit heavy duty, but we're definitely going to move on. The temperature I've divided over 2 weeks, so I'm not saying if you get behind here that it's okay. You'll have time to make it up for the temperature, but I kind of built that in a little bit, but until we actually do it and run it, I don't know. We'll see. So that's what you got. Enjoy the rest of your weekend. That's what I got. Bye.